Hello guys, welcome back, welcome to my channel. Now again we're going to talk about, this one is the MECCALTE AVR and this one is the ER. Okay, if you are familiar with this AVR, then comment down below to our channel so we can talk about it. Okay, so this one is DR1 we are talking about today, and I will show you now the picture of this AVR, because this one is almost same with the DSR AVR, which is the only the different this AVR is having the multiple ranges of the voltage. You can select that one, and this one is having the three-phase sensing, while the DSR is only the single phase sensing and the range of the voltage you can select for that one. There are two selectable range for the voltage, while this DR1 have a lot of options you can do. Okay, so let's jump up to our topic today. Yala. So okay guys, now we're going to start up our topic. So once again, this one is DR1 digital regulator, and this one is by MECCALTE alternator. So let's jump up directly to our technical guidelines, and here is our specification. So this one is the DR1, which is not a big difference for our DSR regulator. The last my previous blogs before, so you can also check that one if you want to see what is the differences. So let's read it from here. So DR1 is the voltage regulators for synchronous alternators and designed for the standalone working. Okay, almost the same. So this maximizes the performance, and the regulator should be intended as part of the systems made up of the least three components. Same as least component, they have the PD or the drop, that one, what we call that one, the drop adjustment, and there the other one is the filter, also that one, and there also you can connect the configurable switch for if there is common alarms happen to your AVR, you can use that one. I forgot that one, the term. I will check it from here because later on I'll show you also that one, that particular device. So I'm searching that one from here. Where is that one is mentioned? So I cannot find it. I think no, not this one. This is what we call the PD or the drop, this one. So I will check it here. Where is that AVR module? So yeah, this is the one. Is DR128, same as the DSR. They have this device also, and you can connect also this one to your laptop using the USB 2D XR. So this is the connector, which is this one is for your interface for your laptop. Okay, so let's jump back to our characteristics of this AVR. So as I said, this one we can connect to the communication module using the USB to DXR, so same as the other one. So this one also you can use that module. So they have the three components. You can use this device for your specific usage for that one, like synchronizing and the rest of your what you want to do with it. Okay, so So this one is not necessary. So let's go from the technical characteristics of our digital AVR. Okay, so technical characteristics of this device is installed on board. So digital control regulator based on the DSP or the display. This one is suitable for all MCC alternator, self-regulated alternator. So power connections through 20 poles, fast on connectors. See the configurations number 2. So power connections, again, protections, power winding with 5 amps, same as the DSR with the 5 amps also. So, and fast acting fuse. Okay, so signal connections, peak 60 Hertz, jumper APO through 10 poles, mini fasts on the separator connections, which is this one is environmental temperature is up to 25 to 70 degrees Celsius. I think this one is the what we call that one is the working temperature, I think. Yeah. So the voltage supply is 40 VSC to 270 VSC. This one is from the auxiliary winding output voltage or also from the PMG. Okay, this is this frequency range up to 12 Hertz to 72 Hertz. Okay, 3-piece or single-piece sensing is all connections with the Y, delta, double Y, and double delta. So this AVR you can apply with the big Y, big delta or the series delta or the series Y, the double Y, and the double delta connections. This is applicable for that. Now next is single piece and 3-piece sensing automatic recognitions. Okay, so average value of the voltage regulations range sensing from 75 VEC to 300 BEC. So they have the bigger range rather than the DSR. Okay, precisions of the voltage regulations at 1% plus minus from no load to nominal load in the static conditions, with any power factor of the frequency variations ranging to negative 5% to positive 20% of the nominal value. It's almost same with the DSR. And precisions voltage regulations is 0.5%, stabilized conditions, load temperatures, transient voltage drop over voltage within plus minus 15%. So voltage recovery time within 3% plus minus of the value set in less than 300 milliseconds. Okay, programmable soft starts, parameters, volt stability, amps and hertz by timers default up to 50 and 60. This one is settable by the jumper. Okay, so settable by the jumpers means you have the connections, this one. Okay, either it is closed or open the connections. Okay, so remote output voltage is through external potentiometer from 25 kilo ohms. Oh, this one is a little bit bigger, 25 kilo ohms to 100 kilo ohms. Okay, so over voltage, under voltage alarm, excitations, current protections with delays, interventions, under excitations, alarms, loss excitations, management, temporary short circuit, start up the synchronous motor. Okay, the same with the DSR. So let's go to our terminals numbering. Okay, terminals numbering, which one? This one is having a lot connections rather than the DSR. DSR is only, I think that is 15 pieces, while this one is up to 32 connections. Okay, let's start up to our connections. Terminal number 1, this one is standard. The excitation connections, which is this one is negative, and the number 2 is your excitation connections. To the exciter, it is positive connections. Number 3 is your common auxiliary connections. Then it is ranges to 40 to 270 VSC and the frequency of 12 to 72 Hertz. Okay, so now the excitations rating, this one in the continuous rating is up to 5 ampere DC. The transitory, or this one is the what we call transitory, means this one is only limited time, like it's split seconds only, or a split split seconds only. This one is around up to 12 ADC at the peak point. Okay, so next is our number 4, which is stated here, the UFG sensing. 5 is the UFG sensing also, so meaning this one, this range is number 2, which is up to 150 to 300 volt EC, and the burden is 1 volt ampere. Okay, so number 6 and 7, which is, you see here, you have the white and the gray color. So this one, the white one here, the 6 and 7, which is UHG sensing. This one is both the sensing number 1, which is the range of 75 to 150 VC. The burden is 1 volt ampere. Okay, so here also the short for sensing is 75 to 150 VAC. Okay, 8 and 9, this one is UHB, UFB. This is jumper range, so this is the jumper, so you have to jump only this one. Okay, so this one is for the range number 1. Okay. So this one, we have here the sensing number 1, and we have also the sensing number 1 here. So meaning they have the ranges of, yeah, same. Okay, so let's go to number 10. So this one is connections UFB. This is all related to the sensing number 1. So this one is range up to 75 to 150 BSC. And the next is that 11 is UFB. So this one is part of the sensing number 2, which is, this one is the range of 150 to 300 VSC. Okay, so here is number 12. You have the UFB, and this one is joined with the 3. So UFB, so this one is 13 is not present, and this go for the 14 and 15. This one is VFG sensing, and this is ranges up to 150 to 300 VC. This one is V channel to be connected in parallel to U channel in the case of the single phase sensing. So okay, so we have here the number 18. It is not present also. Same with the, okay, so same with the number 13 is not present also. So let's go for the number 19. This one is WFG sensing, which is the range of 150 to 300. Okay, this one is the range of number 2. So the gray, see, you see the color number gray. So let's go for the 20 and 21. So this one is WHG and WHB, which is range up to sensing number 1, which is the voltage range. That one is 75 to 150 volt AC. Okay, so there is no confusing this one, because you can see the color coding of this one, which is only related to the ranges of the sensing. Either this one is a single phase or the 3-piece sensing connections. Okay, so here in the 22, this one is WFB range, so meaning WFB is up to 150 to 1300 VSC. So the color, this one is the gray. So if you see the gray color, This one is range up to 150 VAC. All the gray color is, that is the range number 2, which is 150 to 300. And the white one is range, this one is 75 to 150, whatever the connection. This one is 75 to 150. Okay, so now let's jump up here from the 23 and 24. Which one? This one is common for your APO, or their active protections output. So APO, this one you can this one is configurable output. This one is like a dry contact only. This one is normally closed contact. I mean normally closed, or no, I think this one just check this one if it is if you tested this one, if closed, then this one is normally closed. See, this one is, you see, this one is programmable, active level, activating alarms and delete time. Okay, you can do the configuration for this one if you wanted. So this one, the current is up to 100 milliamps, voltage is 30 volts maximum. Okay, I'm not sure this one is normally open or normal close, but I saw this one, like, I think this one is normally open, or like this, it will active at close. Okay, so let's go from the 25 to 26. This one is common from your jumper if you want 50 or 60 hertz. So 50, this is a open, no, wait, okay, this one is, I think, yeah, 50 is open, and if you want 60, this one is closed. Okay, so next is 27 and 28. This one is external potentiometer, which one you can use, as I told you. This one is 100 to 250 kilo ohms, they are stating there. Okay, so down here is your input remote voltage. This one is the OXT. Okay, then this is the remote voltage input control 0 to 5 VDC. Okay, so this one here is your for the you can use this one as your potentiometer. Okay, this one, the 30 and 31. So this one here, the 27 and 28, this one is your remote voltage from range to 0 to 2.5 VDC. Okay, or this one is yeah. Okay, so number 32 here is your plus minus 10 volts, which is so this one is the external, same. This one is the input for the voltage, not insulated. Okay, so this one external, so this one is voltage input. Okay, this one is range up to 0 to 10 VDC. So I think this one is, I'm so confused. Either this one you can use as the voltage for the connections for your paralleling, or this one. See, let's check it from here. Terminals, number 1, note number 1. This one is terminal are connected of each other, which is board 2 and 3, it is connected, and 4 and 5 it is connected. So let's see here, 4 and 5, yeah. So 1, 4 and 5, that is connected. This one is here, so that is connected. 3 and 2 and 3 it is connected. So 2 and 3 it is connected, so that's why this one here is the same auxiliary excitation, so this one is disconnected. And 6 and 7 it is also connected, so that's why it is both white. both gray. That one is all both connected, so meaning it does 89 is also connected. So here is 9 and 10. So 9 and 10 it is connected. Okay, so 9 and 10 that is connected, you see here. Okay, 6 and 7 it is connected. 9 and 10 is connected, and 11 and 12 is connected. Okay, 11 and 12, where is the 11 and 12? Yeah, this one, same UFB. Okay, because this one is only different in range voltage. Okay. So number 2, note number 2, maximum power voltage is 40 VAC up to 15 to 115 hertz, 100 volts at 50 hertz, 115 volts at 60 hertz, and 50. Note number excuse me. Note number 3, with the external EMI filter. This one is what I told you. This one is the 182K. This one is the external filter. So 50. Note number 4. This one is 50. 100% EHZ, 60 100% at EHZ, where EHZ is positions relative the hertz trimmer percentage. Okay, so EHZ said to here, this is related to your hertz trimmer. Okay, so note number 5, value not be exceed, value not to exceed the effective range depends on the parameter. So starting from the versions 19 firmware. So here I think this one is the voltage calibrations is from 75 to 150 VSC. So stability, hertz, as I told you, this one, if there is some fluctuations, this one is you can adjust. Hertz and amps, this one is only the protections you can adjust, where you can put 100 or 100% or 50%, depends on what you're needed. Excuse me. This one is the block diagramming for the AVR, where it is connected all the wirings. Okay, so let's go to our next here. What is that? So as you can see here, these are the same also. They have the color coding, which is the gray and the white. So as we can see here, this one is all the connections for your alternator. So this is the voltage you can get for this connection. So here is the series star, which is the range of the 380 to 500 volt AC. So it's stated here also from 260, maybe that one is very the lowest voltage, to 500. So this one is you can get at the series star connections, where you can get the sensing. This one is the single phase on the half phase, 3 phase on the half phase, single phase on the half phase, 3 phase on the half phase. So here is the voltage you can get from these connections. Okay. 500 to 960 voltage, this one. Okay, this is from 520 to 1000 volts. Okay, so as you can see here also the parallel star connections, which is you can take the voltage from 190 to 250 volt AC. So this one is range from 130 to 250. This is the lowest voltage. Okay, so also here you can take 380 to 500 volt AC. This one is your connections, which is each is single phase, each is 3 phase, and this one I think they have their designated information. This one. Okay, so series delta, you can take 220 to 290 range. So here is stated is from 150 to 300 BC. So series delta, you can take this one 305 to 555. So here it's stated that the lowest is 300 to the highest of 600 volt AC. So parallel delta, you can take this 110 to 145. So it's stated here from the lowest to 75 to the highest of 150 volt AC. Okay, so down here you can take 152 to 277. So the lowest is 150 to 300 VSA. Zigzag connections, you can take 300 to 430 VSA. Here stated down is 260 from the lowest voltage up to the range of the 500 volt AC single phase phase parallel. So this one have the 220 up to 290 ranges. So here is the maximum, the lowest voltage is 150 to 300 highest voltage. Another one here is 305 in up to 355 volt AC. Lowest voltage you can get is 300 to 600 highest, low to the lowest 300 to the highest of 600. Okay, this alternator is capability with the rated characteristics of the alternator, sensing only full phase. So DR connections for typical applications drawing should be this one. If in case the sensing is 75 to 100 phase volts with half phase reference, this typical drawing 3-phase connections is, so this is the references. While the single phase is it in the AC, this one is, you can refer this one. ACC is 160 like this, blah 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 blah. So what else? Okay, here we comes to our connections. So this one is our sensing connections, which is 3-phase sensing connections. This one is stated here. You can apply from the range of 75 to 150 volt AC. Okay, so here is our connections. So I will little bit zoom in more so you can see. Okay, 1 and 2 is your exciter connections. It is connected from here, exciter, and the rest is Z2 and Z1. This is your as I told you, this one is your auxiliary connections. So it is connected here, and the number 3, Z2 is the number 3, and Z1 it is connected at your number 12 connections. Okay, so the rest of that is the P1 is disconnected from your group or this is your PD connections. Okay, it is only like a series connection. So P1 going to number P1. So this one is connected up to 3 in the 3 numbers of your winding, which is the 1 coil only, directly to the 4. So 4 it is connected from your number 11. Okay, so next is our, this is the jumper, which is 8 and 9. So leave it that one jumper. And next is our number 7, which is connected in the number 7 winding connections. Going to the number 8, which is 8 is connected on in your 16. So okay, so this one is the sensing line 2. Okay, so since this one is 3-phase, so you have to do the 3-phase connections. Okay, next is our last connections. So this one is 11. It is connected from your number 20, and 12 it is connected in your 21 connections. This one is the line 3. Okay, so you have the 3-phase sensing with the range of 75 to 150 volts. So they have the different ranges. So here is our 3-piece sensing connections, which is the range of 150 and 300 volt AC. Okay, so first, same 1 and 2 is the exciter connections, positive, negative. Z2 is number 3, which is your auxiliary connections, and it is connected in number 12. Okay, so the next is P1 is your PD connections for your droop, which is connected also to number 11. This is P1, so P1 is going to number 3, which is number 4 is out, going to your 4 connections, which is connected to number 11. So next is our second connections, or the second sensing, which is this one is number 7, which is connected in the number 14. And if you see here, number 14, 7, here is the connections, which is 7. So 7, it is out of number 8, which is 8 is connected to your number 8, which is number 17 in the AVR. Next is your third connections for the line 3 connections, which is number 19, and it is connected to, where is your 19? So 19, it is number 11 connections, which is go through here at 11. As you can see, it is 11, it is 12 out, it is 12, it is connected to your number 22 connections. So here is the link, which is your this one is your potentiometer. This one is the 29 and 30, GP1 27. This one is already have the link, do not remove that one, just leave it like that. And this one is your 50 and 60 hertz. Okay, so all our connections are the same with the range, only the sensing terminal only is the difference between your range of the voltage sensing. So here is your 75 to 150 range sensing. This one I think 3-piece, the same 3-piece, 75, yeah. So this one is already at single phase sensing connections. As you can see here, 1 and 2 is the same as your exciter connections, and here is 1 and 3. Sorry, this one is 3 is from your Z2, which is your external auxiliary connections, which is connected here, and the number 12, the JID1. So this is the out, in, out, like that. So P1 is your PD connections, which is connected to your 3, and out of your number 4, which is 4 is connected to your number 11. And the rest that one, because since this one is single phase connections or single phase sensing, so this one is you need only to do the jumper for this. So the rest of the sensing they can take also. Okay, so they make the jumper for that one. They have the jumper for 7 and 15. They have the jumper of 10 and there is the jumper for 7 and 15, and 10 and 16, and 19 and 22. So this one is for the single phase connections. The range of the voltage is 75 to 150. Here's the next connections is from single phase sensing to 150 to 300 volt AC. So standard 1 and 2 for your exciter, and Z is always at the 3. This is your auxiliary connections, and the out for that one is going to the 12 connections. So okay, so number P is for your drop connections, which is connected to the number 3, whereas is the out of 4, which is connected to the 11. The rest of that is so P1 is connected at 5, so it's out at the 11. So 4, it is connected here. They have the jumper of the going to the terminal number 4, and the 10 connections is having the jumper of the going to 17 terminal. So 19 terminal have the jumper going to the 22 terminal. So here is the connections of your sensing, single peak sensing with the range of the voltage of 150 to 300 VAC. So here is the sensing for single piece, which is 300 volt to 600. So we have a lot of ranges of the voltage: standard 1 and 2, auxiliary connections, 3 always the Z connections for your external auxiliary, and this one here is the out is number Z2, which is connected at terminal number 12. So your ratio P connections is number 14, number 3 connected, and the out number 4, which is number 11, 14 and number 11. So the rest is that is only the jumper and the jumper for your sensing jumper connections. Okay, so this one is not very difficult to understand, because if you just follow the diagram for every on each ranges of the voltage, it is easy. So same with here, we have the having of single piece sensing for the zigzag connections. So here all is stated here, so it is not difficult for you. Just follow of all of this diagram, so it is not be confusing, and there is no mistake happen to you. So 1 and 2 is same as the auxiliary standard connections for your exciter. Z3 is terminal number 3 is this is the Z2, always at your external winding connections. So G2 out, this one is going to number 12, G1. So your P1, it is 14, which is number 3, that is out of 4. And so this one have the different connections, because this one is the generator 3-piece zigzag. So as you can see here, it is big difference. This is 3, it is joint with the 11, 7 and 3. Okay, so 3, it is out from number 4, which is joint also at your number 6. Okay, connections. So here number 6 connection, and out from here like this a 5. So your P is number 4 and 3 is 11 for P1. So here if we see follow, this one is disconnected at your I mistakenly your P1, it is connected from your number 1, which is connected at number 2, which is linked from number 12, and it is linked from going to number 3 up to here. So that's it. The rest of that one is your jumper connections, which is 4. It is connected to the terminal number 7, and this is terminal number 19, which is connected to your terminal number 21. All the rest is here, is not yet changed, depends on how the way your connections is needed. And that's it for the connections of all the ranges, which is the single piece, the 3-piece connections is all is there. So you just take a look for all the diagrams for that, so it is not difficult for you. So remote control voltage or PXN port terminal 30 up to the positive negative 10 volts terminal, which is number 32. It is allowed to obtain the remote control's output voltage by the means of the DC signals or an external potentiometer. So this one is needed for your external potentiometer, which is the range of the positive negative 10 volts. Okay, so here also is stated that the output voltage can be controlled by the software as well as with the page number 19. So you can rely that one at the page 19. So all there is discussed all about this topic. Okay, so the rest of this one is the exertions, the range of the gains of the remote controls can be set as dependently at the software despite of the output of the voltage control systems. This one is DC signal, which is page number 19. All is this one is here is stated. Just relate this one. So jumper number P1, jumper P2. This is the voltage exceeding of what is this? This one is connected between the terminal and 29. This is subjected by the jumper exceed information limit. So that one, the G1 and the G2 terminal jumper, this one is only for the information limit. Okay, so RAM voltage control settings, so not necessary that one. So here is the graphs for that, and this one is the range for your voltage potentiometer, which is 100 kilo ohms linear potentiometer. And okay, so here is the connections for that. So you have the 100 kilo ohms variable resistor. So this one is the connections, which is here you have to jump the other side. Okay, so here is the line and the other line, which is connected to the terminals 28. This one is 29 and 30. So as you can see here, it is jumper of the jumper for your terminal. Okay, so just rely on this. But here in the external potentiometer, if you are using the 25 kilo ohms variable resistor or the potentiometer, this one you need to have the 3 key resistor. Okay, 3 key 9 resistor, which is in series connections with the 29 terminal and with the jumper of your here. Just follow these connections so it will work properly, because if you didn't follow, it will not work. Okay, so terminals in the bolts of software to extra terminals, blah blah blah, bolts and nothing. So here is your connections and for the laptop itself. Okay, so the rest of this is not necessary, and this one only the specifications and the voltage range, and that is not about almost the technical. This one is for relies on the way you config from the laptop. And for now, I don't have the time because I need to prepare myself, because it's time already for our punching out. So I think I'm done enough for this AVR. This one is not much different with the DSR, only the options and the additional terminals is there where you can use it. Depends on your project, or depends on your usage for this one. So again, don't be confused. Follow all the diagram connections and understand what is the functions with these connections, so you can use it that one correctly at what your project is you are working on. Okay, so by the way, if you have some questions or doubts about this topic, then you just comment down below so I can review all of this, and so I can answer also what is the questions you sent to me. So I will check on that matter so I can answer to you. Depends on what is stated here, and we share our knowledge about it, and so we can resolve all the problems that we have in case that we're having the trouble for these connections. So once again, benzblog is here. Thank you for watching. See you again in my next vlog. Bye bye.